Okay, so from the last time, I have my environment changed a little bit. I had a management switch which was connecting to all the routers and switches initially, but now I just removed the management switch and I have sub interfaces configured on all the routers and switches. Um, and those sub interfaces connect to the NMAS. Um, Previously, my NMAS was just an Ubuntu host, an Ubuntu server, which was launched by the Docker built-in image, but I changed it to my own VM that was assigned to me in this course. So this is not the NMAS, and this is the VM that was assigned to me. And this is the SNMP NMS and the data log collector, which I will show you how I do it in a bit. Okay, so first things first, I configured SNMP on all the devices, as you can see here, and I have community, private, and public. And the SNMP server host or the SNMP server is this IP address, which is essentially the IP address that I assigned to on my VM. So if I do config Ethernet 1, you'll see 192.168.100.2 is this IP address, and this is the SNMP server. Also, I've enabled traps. Essentially, if any of the links go down or if they come up, then it'll send a trap to the SNMP server. And I've configured the same everywhere else. As you can see, I've enabled traps here and here and everywhere else. So that was about SNMP, and that's how I configured SNMP. The next thing is talking about my NMS setup. I am essentially monitoring, or the VM, the NMAS, is monitoring the CPU utilization of all the devices through using one OID. So I have a service called monitor CPU.service, which essentially is running in the background and it runs this script that I wrote. And what this script does is, this is the OID that is used for monitoring the CPU utilization. And this is the log file where I'm storing all the logs for the CPU utilization for all these devices. And there is a database file which I'll talk about in some time. And these are all the hosts that I am monitoring. And the interval is 300 seconds, which is 5 minutes. Um, so my NMAS is polling for CPU utilization percentage from all these devices every 5 minutes. So I'm doing an SNMP walk on that OID that was mentioned above to get the CPU utilization. And essentially, I am storing a table called CPU utilization, um, which is an SQL database. And this database is stored in var log netmanlogs.db. That's the database. And if you see, there is a table called CPU utilization here. If I do a select star CPU utilization, it will show me all the CPU utilization and it runs every 5 minutes. So as you can see, the first one that happened was at 16:13 hours, and then it happened on 16:18, then 16:23, 28, and so on and so forth. The good part about SQL database is that I could tweak my select queries or get queries to just get for one host or some timestamp or utilization percentage. Like, for example, I could do something like where host equals 192.168.100.5. Let's say this is the IP address for R1, and I see all the CPU utilization for R1 throughout the day. This is in percentage. So at 1613, it was 16.66 percentage, and then it was 12.88, 15.66, and so on and so forth. So that's how I'm tracking CPU for all the devices. Now I'm going to talk about how traps are received. As you saw here, I had traps enabled for any link failures. I have another script for traps. So I have another system D service called SNMP trap service, which runs this command in the background. And what this command does is, so it is essentially running a TCP dump and listening on port 162. So if any trap is being sent, it'll be sent to NMAS at port 162, and the NMAS is listening on port 162 to catch any traps. Once it catches the traps, I am basically extracting the necessary information, like what is the host IP address, what is the interface in question, and what is the status of the interface, like is it down or up. And I'm essentially storing all of this information in a table called SNMP traps in the same database as CPU utilization, which was logs.db, as you can see here. So I'm going to show you how that looks like. So I have SNMP traps here, and there's nothing as of now. Let me send a trap first. So go on R1, and let's say I shut down ET 2.200 interface. Hopefully, yes. So this is the host IP address, which is R1's IP address, as you can see here, 192.168.100.5. And it says interface 2.200 and the interface status is down. Now if I bring this back up again, it'll log that it is back up again. It also stores the timestamp here. So the only reason it also logs the link up is because I have enabled traps for link up and link down as well. That's why. Okay, so that's how NMAS is monitoring the traps, and I'm storing all of this information in an SQL database. Now, talking about the critical errors. For now, on all the devices, I have configured them to only log OSPF errors or anything related to OSPF adjacencies, and that gets stored in var log netman. I'm going to remove all of these and start fresh so that you can see how that looks. Okay, I've removed all the log files, and I'm going to restart the rsys log service. Status, and it's up. All right, so I will try to shut down the router OSPF agency adjacencies. So now R1 is not talking OSPF. And if you see here, you'll see that it logs three log files because R1 forms OSPF adjacency with all the other routers as well. And this is the log file for R1. And if you see, it says that the adjacency was dropped, interface went down, and state was full initially. And if you see 104, it'll say that the neighbor 100.5 adjacency was dropped. And if I do a no shut and if I bring OSPF neighborship up again, it'll take some time. And it says that the neighbor's adjacency was established. Back up again. And that's how I'm storing RSS log. And all of these log files are stored in a file. Next, I'm going to talk about how I'm using netconf and gRPC. So this is what I have for netconf configuration and gRPC configuration. It is basically listening on port 57400 for gRPC. And I am streaming a couple of data that is that I'll show you, and I'm storing all of that information again in the SQL database, and I'll show you how the data looks like. So I have another table called interface stats, which I created. I'm sorry. Let's go again. Upload table. Select star from interface stats. And as you can see, I have a couple of data that I am polling, that I'm streaming almost real time. And these are all the interfaces that I'm tracking for all of these IP addresses. Like now let's just focus on, let's say this 100.5 for now. Equals 192.168.100.5. All right. So I just filtered it to show only R1's interface stats. And I have interface name, the MTU that it has set for each particular interface, how many packets are flowing through that interface, how many packets are going through that interface, what is the speed of the interface, and what is the status, and the timestamp at which it was logged. So it is essentially polling real time. And if I had to like just show you a demo of, let's say, let's take down Ethernet 1. I do a shut and the interface goes down. Now I'll bring it back up again and let's change the MTO to 9000. And as you can see here, Ethernet 1 MTU has been changed to 9000, which it was previously 1500, and the status is back up again, which was down before. So that's how I'm pulling information and I'm storing it in this database. And as far as data lake is concerned, as you can see that I am storing all of the information in an SQL database, which can be used later on for visualization with Grafana. And yeah, that's it.